All
right, yesterday we started working with utilizing our calculator a little bit more to be able to come up with function values. And hopefully, once again, as sort of a KYC, know your calculator type of exercise in regards to determining your calculators, or utilizing your calculator to be able to determine functions. Once again, you have your y equals, you can type in your function that you have, and your y equals up there. Couple ways of going to it. We can go to second and table set and set your table to any values you want, your domain and your increments there. And that will give you second and a table. You can come up with a table then at that point. Or the second way is second and calculate, and you can calculate values for your function where the function will come up and it'll ask you what x values you want, and you can type in an x value and come up with a y value then. So either way is a correct way of doing it. I've done it both ways. I utilize both the tools when I'm going through certain things. It's a little bit more prevalent for when you're in calculus. When you get to calculus, to be able to come up with specific values makes it a little bit easier to be able to do it this way. Questions you have about your calculators, anything with it is a work in progress in regards to getting used to how to deal with calculators a little bit. And you just need to do practice with them. You know, that's what I've always learned with respect to utilizing the calculators. Sometimes I have to go through a couple of examples and me trial and error, and sometimes it doesn't work. It is very similar to what I have to do with technology sometimes, where it doesn't come to me quite as quick as it comes to you guys, because you're a little bit more used to the technology. Okay, I'm at home and I want to get something on TV. We have regular cable still, so we don't have Yahoo or Yahoo or Hulu or whatever TVs, but we do have Netflix, YouTube, and stuff like that because of the granddaughter. We want to be able to get certain shows on there. Well, sometimes it takes me a little bit to get the correct slide and the correct thing to be able to figure out, okay, right, to get what I actually want from my granddaughter. It takes me a little bit of time where if my daughters are home, here, do this, and it's done. To me, it takes a little bit longer. So, and that's the same thing with respect to your calculators and things of that sort. To me, it's a little bit easier because I've done it time and time again. To you, it's a little bit newer to you, which takes a little bit more time. Questions you have at all? Once again, that was the main focus of the second day of the homework. Do we actually have to go through a second day of homework with that? No, I think you could have figured out after one day. But my goal yesterday was more or less making you utilize the calculator to be able to come up with the data values and the values that you want. Once again, what I need to see on a test, I need to see a table of X and Y's if you want. If you want to copy them down, that's fine. Or take from your calculator and put it down there, that is fine. Or a list of ordered pairs, that's what I need to see. All right, questions you have? All right, we're going to go one more day of domains and ranges, but it's going to be a little bit different now. Once again, my philosophy on homework is for you to get extra practice, for you to practice what we've been dealing with. If you have issues or problems with respect to homework problems, you need to ask, okay? Because I'm not going to go through every single problem, go around the room, and what do you give for this problem? No, I'm not going to do that, okay? It's practice for you. If you need something more explained, I tend to have a good feel about what we need to get to. If I need to do extra problems up here, I'll do extra problems together. But for things like this, if you need me to do problems, that's fine. Just you need to ask. But This is practice. Just like if you're on a sporting team, you have to go to practice. Okay? If you're in the band, you have to go to practice. Okay? If you're in a play, you have to go to practice. And you practice what you're dealing with. That's what homework is. That is practice for you. Okay? But it's the academic practice for you. And that's the philosophy I have with respect to homework. I'll give you in-class assignments at times that will grade your capability of being able to do certain problems, but not at this point. We're just going to go through and continue to go through. Today we're going to continue with domains and ranges. But now we're going to take a look at graphs. Now these graphs will have arrows on them. Okay, all the graphs, I wasn't able to finagle technology-wise the arrows at the end of those things. So they're there, they're implied being there. Okay, but what we want to be able to do is take a look at a graph and determine the domain and the range. Okay, well, when we're talking about the domain, that's your x values, your range is your y values. The set of all x values and the set of all y values. That is your domain and that is your range. Once again, that's just going back to definition. Going back to definition, and as we always talk about mathematics, you can always refer back to definitions and try to apply the definitions to the best of your ability. Okay? So when I'm talking about the domain, we're looking at the graph here, and we're looking at the set of all x values. Well, what we've done up till now is I've given you a list of ordered pairs. But what we talked about on day one, when I take a look at a graph, how many points do we have on this graph? How many points lie on this graph here? 1, 2, 3. How many points do we have on this graph? How many points lie in that? Infinite numbers. You have an infinite number of points. So every one of these, all along here, we have an x value and a y value. We have a point here, an x value and a y value. We have here an x value and a y value. We have this point right here, which is an x value and a y value. We have this point over here, which is an x value and a y value. We have this point here. We have all these points here, and all those points all along that graph have an x and y value. So what we have to do is take a look at the graph, and we don't have actual numbers here with respect to this point right here, and this point right here, and this point right here. We don't have actual numbers there, but we can describe in general what is our x values and what is our y values. Well, here we have an x value, this x value here, this x value here, this x value, this x value, this x value. We have all these x values that we use here, and it continues on. And all these x values that we use along this number line here. And it continues on to the left and to the right. So if I'm going to describe my x values, how can I describe my x values that I have here, all these x values here, all these x values, and this continues on to the left and right? How can we describe them? Infinite number of x values. Now, mathematically and numerically wise, in numerical systems, what do we call that? How can we classify it in regards to numbers and compare it to the idea of numbers? How can we describe that with respect to the numbers? Okay, there's an infinite number, but how do I describe that? All these numbers. How do I describe? What do we call them? What can we call them? Go beyond just infinite number. How can we describe all the numbers? Ooh, we're getting close. We're getting close. She said all rational numbers. But we can further go beyond that. What's more than rational? What's the next level? We have whole numbers, we have integers, we have rational numbers. What's the next? What's the next?
Real numbers.
Real numbers. The rational numbers are just all your fractions. Rational numbers are just fractions. Okay, but we have square root of 2, which is not a fraction, approximately 1.414. Square root of 3, which is not a fraction, approximately 1.732. Okay, square root of 5, square root of 10, square root of 7. Okay, we have all those values there that aren't the rational numbers. But any fraction, 5 over 3, is part of that. But we can classify basically the entire number, basically it's the whole entire number line. It's the whole entire number line. We can classify them as all real numbers. That is the category of all the numbers. So we have all real numbers. All real numbers. Those are numbers that you can put into your calculator and calculate. Those are real numbers that we can put in the calculator and calculate. So how do we write that down? Okay, all real numbers. Well, we need to first get that we have set of values. So we need to get a braces there. How do we write all real numbers in mathematical terms? Okay, we're talking about our variable x. So we have set of values x. We put a colon in there. This means such that. Set of values x such that this x, and then we do a half symbol or half circle with a line through it. This is an epsilon, lowercase epsilon, means is a member of. So we have a set of values x such that x is a member of the reals. And we use a capital R. Now, if you just have a big R there, that is fine. The double line means it's bold-faced, which is mathematically a little bit more acceptable. But this is just a capital R. Set of values x such that x is a member of the reals. Now, if you just have this right here, that's fine. X is a member of the reals. If you just have x is a member of the reals, that is fine. This here takes you to that next level and stretches you a little bit in regards to your terminology. If you don't have it there, it's no big deal. Not a big deal. I'm not going to count wrong because you don't have x such that. If you have set of values x is a member of the reals, I'm good with that. Okay, I'm fine with that. But once again, this is once we are getting to a point of advancing ourselves in our mathematical knowledge. So this is an opportunity to advance yourself in the mathematical knowledge. All right, just look at the range. With every one of these ordered pairs, we also have a y value. These are your y values. We have all these y values here. We have all these y values here. We want to describe the y values. Well, verbally, just a description, how can we classify the y values that are in all these ordered pairs? Okay, once again, we're just looking at all these ordered pairs. This ordered pair, this ordered pair, this ordered pair here, all these ordered pairs. How can I describe my y values here? Okay, y is between -2 and 2. Y is between -2 and 2. That's how we can describe it. My graph does not go above 2. my graph does not go below -2. I don't use this y value of 3 up here because there's no ordered pair, there's no graph at the 3 value. I stop at 2 and I bottom out at -2. So now how do we symbolize that? Y is between -2 and 2. So we have a set of values y such that, okay, once again, what we do is we symbolize that. So the values y is such that, once again, if you don't have that there, that is fine. Okay? Now, how do we write between -2 and 2? Well, the easiest way to think about this is I'm going to put y here, and I'm going to write -2, y in between -2 and 2. Just way set back there. Okay? I'm writing and verbalizing exactly what Noah said. Okay? Y is in between -2 and 2. So now symbolize-wise, what do we do symbolization? We use our less than greater than symbols. Okay, if this is the smallest value here, you're always going to point them to the left. Now it looks like we touch. So I'm going to throw equality in there, less than or equal to, greater and greater, less than or equal to. Because it looks like we touch there. But on some of my graphs that you'll see, it looks like we touch, but it's not quite touching. You know what? That's okay. If you just have less than greater than. So this is our range for this graph here. Now the next question is this a function? Well, going back to definition. Definition of function is a relation such that each value for no domain corresponds to exactly one value in the range. So if I take a look at this x value here, does it correspond to one y value? This value, does it correspond to one y? This x value here, does it correspond to one y? This x value here, does it correspond to one y? Is it a function? Yes. Now, can it go to the exact same value? Is it okay that it goes to the same value of y? Yeah, we're okay if two different x's go to the same y, just so it goes to one y, because this x value goes to this y, but this x value goes to the exact same y. That's okay. It's that one x that goes to two different y's. Now, you learned something in algebra that allows you to do a little test in regards to a graph, it's a function or not a function. Does anybody remember what that test was? Vertical line test. You have the vertical line test. The vertical line test. Draw a vertical line. Intersects graph at more than one point not a function. If a vertical line can be drawn to intersect at more than one point, not going to be a function. And the reason why is if it intersects at more than one point, that shows you that one x value goes to two different y values. So yes, this is a function. And a little sidebar, this here is a graph of a sine curve. Okay, when we get into graphing a sine and cosine, the roller coaster is a sine curve or a cosine curve. Okay, once again, we have arrows here. This looks like it's about a half. Looks like it's about 0.5. Write down a domain, write down a range, and state if it's a function. And check your answers with somebody around you. What would be your domain? What would be your range? and state whether it's a function or not a function. What is the domain? What is the range? State whether it's a function or not a function. Check your answer with somebody around you. Once again, check your answer with somebody around you. This is where you help yourselves out a little bit, help each other out a little bit. All right, take a look. Domain, Nick, what do you have for the domain?
X such that X
Is a member of
number of real numbers.
reals. Can I tell you set of values? Set of values, get your braces in there. Need to make sure you get your set of values in there. That is your domain because we extend that way, we extend that way, so we do the whole number line with the X. Range, what's our Y values here? What's our Y's, Marv? What do you have? Can't hear you. Throw it out there. Hey, I'm okay. What you realize in this class is most of the time I'm not going to be asking, looking for hands. Okay, I like to spread the wealth within the class. Okay, so don't feel that you can sort of hide there because I'm not going to raise my hand and he won't call on me then because I won't. I like to ask. I try to hit everybody on a daily basis. Okay, so I try to hit you. Okay, what do you have? And this is also why I ask you to help, check your answer with somebody around you a little bit. Because if you got the same thing as Noah does there, okay, you feel a little more confident with that then, right? Huh? All right, so what do you got? Throw it out there. All right, so do Y, such that what? What's happening with Y here? First verbalize, what do we have here? Y starts here. Okay, Y starts here at 0.5. Then what? There you go. Such that y is greater than, and you know, is it 0.5, is it 0.49, is it 0.51? Nobody can tell. So if you have greater than, that's fine. If you have greater than or equal to, that is fine. Okay, y is greater than or equal to 0.5. So here's all my ordered pairs. Okay, all my ordered pairs here. All my ordered pairs, if I look at each one of these ordered pairs as I go along, all those ordered pair y values are going to be greater than 0.5. You're going to have no values that are going to be less than 0.5 or equal to it, because it looks like it goes to equal to 0.5. This is a function. You know? Yes, it is. Pass the vertical line test. All righty. Once again, we have arrows here. We have arrows here. We have a sideways problem. What's the domain? What's the range? Is it a function? Once again, check your answers with somebody around you. What's your domain? What's your range? State whether it's a function or not a function. Check your answers. Once again, as we go through these, you start to pick up a little bit quicker. Okay. First ones we have to drag a little bit through and pull a little bit, and as we get here to the bottom, you start kicking in the ideas. Okay, this is what I did here. This is what I have to do down here. All right, take a look at this one. Kayla, what do you have for the domain? Set of values. Make sure you get set of values. Set of values x such that x is greater than or equal to -1. I start at -1 and I go to the right with my x values. So all my x values I'm using start at -1. I don't use anything smaller than -1. We take a look at the range values here. Michael, what do you have for the range values?
Set of y such that y is a member of real numbers.
And y is a member of the reals, because this is going to keep going down in this direction here, keep going up in this direction. So if we look at the y values, we're using the entire y number line. Okay, the entire y number line. Function or not a function, Sophia?
Yes.
Yes, it is. Okay, can I draw a vertical line? If I draw a vertical line, okay, vertical line test. If I have vertical line test, vertical line intersects a graph at more than one point, not a function. Do I intersect the graph at more than one point?
Yes.
Yes, they do. So is this a function? No. Oops. Oh my goodness sakes. There we go. So, no, that is not a function. Once again, the reason why is if I take this one x value here and look at the y values for that one x value, I go to this y value, I go to that y value. So I have one x that goes to two different y's. Not going to be a function then. All right, let's take a look at an upside down problem. Once again, we could throw arrows at the end of this. What's the domain? What's the range? Do we have a function? And once again, check your answers with somebody around you.
Please excuse this interruption. Would these 3 students please come to the office? Brayton Tony, DJ Jerry, and Anthony Karen. Thank you.
That sounds like a fake. DJ Jerry.
Like we should be on MTV or. Should be on Jersey Shore, work with Jersey Shore people. Dakota, what do you have for the domain? Okay, member of real numbers. That's correct. Alex, the range?
Y such that y is less than or equal to 4.
Y is less than or equal to a value 4. Is this going to be a function, Jace?
Yes.
Yes, it is. Okay. Last one. Once again, we can have lines here. We can have lines or arrows there and there. What's the domain? What's the range? This is a function. Check your answer with somebody around you. Domain. Brady, what you got for the domain?
Set of x such that x is a member of the reals.
That's correct. X is a member of the reals. Even though we don't have numbers there, this expands this way and this way, which covers our entire number line. Range, Jacob, what do you have for range?
Y such that y is a member of all real numbers.
That's correct, because it stretches upwards and downwards, so it's all real numbers. Size of the function? No, not a function, because if I draw in my little squiggle in there, if I draw my squiggle there, I have one x value that goes to 3 different y values, so that's not going to be a function. not gonna get punched. Question you have? Now, the homework I have up there, you have a worksheet for homework, we just completed the worksheet. You got not us. Okay, we just completed the worksheet. Tomorrow, I'm not a huge Monday morning test taker person, I don't like doing it. But just sort of how the week fell, we're gonna have one on Monday, over basically, finding domains, range, and graphs of functions. It's not gonna be a high intense quiz. It will not be. Tomorrow we have what is called a review sheet. The review sheet is gonna be very similar to the quiz. Okay, I'll give you the review sheet. When you take the review sheet and then take the quiz, it's gonna be almost carbon copy. But change names and numbers to protect the innocent. Okay, so that will be tomorrow and then into Monday. Plus you have 3 periods, sort of prep yourself and then prep yourself on Monday for it. All right, questions you have? Adios. Not adios. QD is done.
It's been a while.